they are. 'Cause I have okay. We started the broadcast. Just need that thing in there to start. I hope I did this right. So, yeah. Okay. Here we go. Theo, this has like a couple of seconds of delay between LinkedIn and this, and we all look sharp. I'm just waiting for Kevin to join us. Yeah, I'll just confirm that Kevin is here, okay, so that we can introduce the things that we are doing. I think over time the overall connection between both the streams in here between we are also live on YouTube. So if someone wants to go and join on YouTube, but we came a couple of minutes earlier. So if someone wants to write some comments on the LinkedIn post and put some questions to the team, or um, just mess around with us and say what is the lunar extract, and who is this team, and any of those things, and how are we going to build the thing. I don't know. and Theo, just we were chatting before. Theo is Theodore. I hope I'm saying this right. um, Theo, can you make a sound check for for this? We already have 9 people on the line. This is going to be fun, fun, fun.
Sure. Can you hear me all right?
Yeah,
Awesome.
sound check done. Theo is our Theo. Theo is
Geoscientist.
our responsible for the for. Come on, dude. Oh,
For test
ah.
track design, for keeping you in line. No. Gonzalo
That's
keeps
true. That's
everybody
true.
else in line. No, I've been working to design the test track to replicate the lunar surface and make sure that all of our components and wheels and excavator and everything have something good to test on, to really make sure that we are doing a durability test and making sure that once we get to the moon, things don't break down. So, been looking into different ways of testing, different grain sizes and testing materials and simulant and all that kind of stuff. So it's been good. I'm a geologist by training, so I've been able to utilize a lot of those skills. But I've learned a lot about space and technology and lunar mining, which has always been good.
Yeah, this trying to bring Kevin in. Is trying to use the link. Um, Still have 5 minutes, so we have time to sort out the kinks. I believe. Uh,
Are we
that-
are we live on there? I think we're live on there.
yeah, we're already live. It's whoever is out there, and like a couple of people who keep on joining us and put questions. We'll be able to see one if this thing works, but if it doesn't work, we need to take the show running. But Kevin is really important in here because um, not only is the CEO of Planetoid Minds, but he also can show us the, the model, correct? Like he can show us the model, and he can show us the. I think he's gonna show the conveyor belt. Okay, he's over here. Hey,
Hey, everybody. You can put comments in the chat. I think there's a public chat on here. Test it out. You can also comment on the LinkedIn page. I'm not monitoring the YouTube. Let's see.
Okay, so Kevin is about to walk in. Okay, he was having some technical difficulties, but like many think, oh, come on, I got a friend of two good friends of mine, Rod Martin. Rod is a beast. He's doing a moon colony. Okay, yeah, and he has his own company where he is trying to sort out the problem of documentation. And we had some of these problems of documentation, correct? Like who approves the document, where does it go to? And we are a small team. Imagine when we move into a team of 30 or 40, or it's going to be pretty hectic. So Rod does that. Rod Mamin, and sorry, Rod is from Lunco Space, and it deals a lot with a very interesting funding scheme in a good way, not a Ponzi scheme, but essentially decentralized finance and decentralized, and what's called it's the Web3 movement. And I also have Craig Prisky is someone that works in sales. He's a top person in selling space business. And he just graduated from the Thunderbird School of Management. So really interesting. In the Thunderbird School, executive masters on leadership for space. So it's like, no, really. And okay, and then another person that I just met just a couple of months, Manuel Constantin Tolaris is on the chat as well and he's working with something called DSci, or decentralized science. And Ted, you'll find this very interesting, man. Is that the idea of decentralized science and decentralized work is really powerful. It's like, it's weird, man. It's weird in a way, because it's like if we could allocate, imagine our work chunks that we had, like, remember when we were doing the design of the test track and where should we put this thing in here? We could have had someone out there in the world, like a third geologist that would help you. We would put a bounty. I just learned this. Okay, a bounty is a way to pay, and that person would give us like a technical opinion. Okay, and it could be anywhere in the world. So they have this massive ability to recruit people. So like, oh, here we go. We have Kevin. Yeah, Kevin. Welcome, man. Welcome.
Thank you. All right, so I have a live stream I can hook in, I think.
Hey, before you start. It's 11:01, so we got on time. We could sort out the problems and the kinks. Okay, that was really nice. Before you start jumping in, can you introduce yourself? Okay, can you introduce this? Introduce yourself. Okay, first of all, that's the and Planetoid Minds and what's been driving you, and then we've got more questions for all of
Okay,
us.
great. Well, I'm Kevin Dupriest. Nice to meet you all. I'm the CEO of Planetoid Mines. We've been working on this for, we started in 2020, but 2019, 18 is when we started the company. And so right now you can see I'm kind of remote. We're in Kennedy Space Center area, Titusville. We've just relocated from Albuquerque, New Mexico, and we're looking for some place here to build some facilities to be able to manufacture and construct our rover. And so, I'm temporarily in my mobile home right now, motorhome right now, and it's a little condensed and compressed, but looking forward to what lies ahead for us. So,
Ted, man,
I'd like to introduce.
Yeah, go ahead. I was about
Okay.
to ask Ted to introduce himself, but you guys
Okay,
feel
great.
free, please.
So we have with us here Ted Miller. Gonzalo Estevez is with us. I don't know if we have any other team members on. I can't really see anything that's
Not
happened.
Okay.
And so we've assembled a really great team to help flush out the design and to put it all together and submit it. So very excited. Very excited.
Ted, can you brief us in again on your job, because you have one of the most fun parts in here, to be fair.
I don't do anything. What are you talking about?
Yeah,
Yeah.
I got the fun job. I get to play in the dirt, I guess. No, I'm designing the test track and the lunar simulant that we're going to be mining. And so the purpose of that is really just to run the rover through its steps and run it through like a gauntlet and make sure that everything holds up. So try to make some rigorous test designs and really look into what other teams have done in the past and what NASA's done in the past to test different rovers, and look for a good facility or a good track for that, like a good natural environment to do that. And then also put in different components, different angles and slopes, and make sure that our lunar simulant is the right strength and grain size and density and all of that. So it's a lot of collaboration too. Kevin knows that we we went back and forth a lot with how to make sure that we have enough volume in the rover to have the right weight. And as we know, on the moon, weight and volume are quite different. And well, volume might be the same, but then again, you have to deal with things like compaction and shear strength and all types of kind of more granular geological thinking. So that's kind of what I've been doing. But for brevity's sake, I like to say that I play in the dirt.
So I'm going to bring us all in, okay? If there is some kind of more focused question, we all take it in or we'll move it along. But let me introduce myself. My name is Gonzalo. I really love the moon, and everyone knows that I'll be an astronaut. I'll put my boots on the moon.
Yes, you will.
That's very clear. If that's very clear for me. So, and when talking with my daughter, she the conversation yesterday was, I'll go first, and then I'll pick her up. Okay, I'll go first, I'll come back, and then I'll pick her up to go there. But what I think is more important from my side is to have the ability to bring space into everyone, and that's like when I made my career change into space. I said like, oh, okay, this is not only for the young. Although I already have some white hairs in my beard, like Kevin. So, but I wanted to ask you a bit more on and anyone can take these, is what is the extract, Kevin? And if you can give us an example of the extract, you can also share screen on the application. It's on the top.
Yeah, we're ready.
Okay. Can you show the extract, please?
Yeah, it's ready. It's uploaded. I think we're ready for the screen.
Oh, yeah. Go ahead.
Okay, here we go. So here's extract. This is our rover.
Woohoo! Yeah!
Yay, there it is. So what we're going to do is try to stop it and slow it down here for a second. And I can show you how it all works. So obviously we can raise our arms. We have bucket drum excavators here that will culminate and spin up. And I have not been able to find my switch to turn the bucket on. I don't know where that went to.
Okay, here they are going up. Okay.
Okay, so they're at least they're going up, and and let's see, we can get them here to go down as well. And so as they go down and they're spinning up, the counter rotating forces will keep it all in. We'll be able to go down and to excavate the whole process. So the other thing is, as it goes down, this bucket scoop here comes and hoists it up. And then inside we have a chevron belt, conveyor belt that lifts all of our regolith up into the mine cart. And that's our storage area for the whole system. So sometimes if I could get it on, I could get it to excavate and drop down. There's a little bit of it, but
yeah, it's gonna start happening.
Not,
Here we go. Here we go.
It's not doing it like I was wanting it to. So there we go. But obviously that's a lot of volume that we're excavating. In the simulation, so it all needs to be worked out a little bit more.
Yeah.
But
So for the guys that are looking into this, and I see a couple of people from JPL, and this is still a simulation. Okay, so it's we're gonna do terraces, and Ted can talk about these, and it might even fly. But just be aware that one thing that I wanted to ask is, Kevin, the counter rotating forces.
yes.
Are a thing, isn't it? And why are they important in this? Of course, our rover doesn't fly. Okay, just make sure everyone knows that our rover does not fly. We need to have something in there that takes it there.
Oh, yeah, I was just trying to reset the system here.
Why is it that we've chosen a counter rotating? And I can help on that, but I would like to hear from you and to inform the people that
well, we're designing it for microgravity. So we want it to be able to fit within the scope of what we're trying to the environment that we're going to excavate in. So although we're going to test it here on the Earth, and this has terrestrial applications, we also need to have the ability to grip. So using what NASA has done with Razor and their counter-rotating bucket drums, we just went ahead and enhanced on that concept. And because counter-rotation forces will grip into the surface and will allow us to have a better handle on the surface and traction that we'll be able to have as well. So, sorry, I'm looking for it. There it is. Lower the arms. But I'm still unable to find the bucket. Speed. So
I think the fun thing in here is that we are following what really an innovation process. That is, we picked up a set of designs, a set of things that we know that work, and we are stitching them together. We are revisiting them. We are making the system analysis, and that whole process, like, oh, these things work, but we need volume. We need the chevron belt. We need something more. Because, and we've discussed, and I wanted to bring this up. I think it's in the, with the team. Oh, okay. One of the things that NASA asked is this needs to be extremely durable. Okay, means at least 15 days on Earth without no one touching it, everything working. And we decided to have all the operations, that is extraction, transportation, conveying, in the same rover versus other solutions that have, I dig, then I transport, then I do this. So we said, no, we are going to go with a full compacted machine around 700 kilos. That's a big statement, correct?
Yeah.
Versus having three machines.
Just hauling 800 kilograms a day. That's quite a lot. So yeah, like I said, the very first system we built was our scale of magnitude. We were able to capture 10,000 kilograms and in one day and do it. So we're like, oh, wait a minute, we need to scale this back a lot. And so, we brought it back down to just doing 2 loads a day at 400 kilograms per. and that will allow us to make sure that our system's durable and tested thoroughly through our operational test evaluation that we're going to do.
And so one thing that I would like to bring a couple of things, and since you brought, we are moving in the durability side, man, I think it's more for Ted. We are going to test it on Earth for the moon. Come on. Do we know what we are doing, or are we just, I don't know, we might not know. Okay, there is a good chance that we might not know, but we are trying to avoid, we are trying to avoid that with good engineering practices. Ted, how is the test track? How does it mimic? I think we have a couple of things that you can show us that are really cool.
Sure. So, I mean, that's a great question. How do you mimic lunar environments on Earth? That's a question that we've been asking since the 50s and 60s. And I went ahead and I asked John Gruner at the Johnson Space Center, and he got back to me. He was great. And basically, we can have this artificial stimulant, and that'll be, I think, a big part of phase 3. When we move on to phase 3, I think we'll get some artificial lunar stimulant by NASA. But he said, for right now, if you're on Earth and you want a bulk, like a bunch of lunar stimulant, let's use bunker sand that you would use in say, golf, of all things. And so he sent me some stats on that, and I've been looking into it. And we have a nice little test area picked out in New Mexico. That's what we're looking at now. And it's this arroyo here. And for those of you not from the Southwest, arroyos are these dry riverbeds that are perennial rivers. You can see here, flows every once in a while, but not very often. And these dry riverbeds are composed primarily of sand. And I told Kevin, well, there's a chance that this could work in our favor. And so I went ahead and looked at, we're a little double vision here. I looked at that dam and I said, well, that dam that was built there certainly had geotechnical engineering done on it. So we tracked down the geotechnical engineers and we got a hold of some great reports that they made, and we were able to look at that and make some comparisons. And from those comparisons, we found actually that if we map out bunker sand right here, and we map out the sand within our arroyo, our planned test site, and then when we map out, this is overlaid on the different Apollo missions and what they found with the lunar regolith. We map all that out, we actually find that our little arroyo happens to be splitting the difference right between the recommendation from Johnson Space Center and lunar regolith. We're actually a little bit closer to lunar regolith than is recommended. So I find that to be a good thing, that we're actually a little bit closer to the lunar regolith than the recommended simulant. So I'm happy with what we have in the arroyo in terms of track testing. This is the phase of the operation where we're testing our wheels and our traction and our ability to go up and down slope. So that's what we're looking at here, and that's all going to happen in this little arroyo. So we have different paths and mining areas and all of that to test our rover on. So pretty happy with that.
Do you by any chance have in there, the graphic that I'm talking about, correct? It's the one where we are in the middle and it's more near.
Say, would we be able to open this up to get some questions from the audience?
Yeah, of course.
Oh, can you not see this graphic? I thought I brought it up.
No,
I have it.
It's still on the. It's still, we have the planetoid moon. We have the track. Essentially, we don't have yet the graphic. Probably it's in another window.
Huh. Here, let me try to share that.
Gonzalo, you're muted for some reason.
Hello.
There
Am I back?
Yes.
Cool.
You see this?
Here it is.
There it is.
What a wonder.
This is. Sorry, it wasn't coming up. That probably didn't make much sense. Okay, so as I was saying, if you map out the grain size analysis for bunker sand, lunar regolith, our little arroyo splits the difference right in between, and we end up being closer to lunar regolith than we do the bulk bunker sand, which was the recommendation by Johnson Space Center. So I'm pretty happy with that. I'm happy that we, are getting to test in an area that's a little bit closer to true lunar regolith grain size analysis. And so, yeah, I'm feeling good about the test track so far.
Yeah, definitely.
Okay, that was very reassuring. Correct. We had a bit of back and forth, like I was like, that's not going to work. So one of the in our team dynamics, one of the very interesting things in here is that we had to push each other. Correct. Like, hey, that's too much or that's too little, and I came up with my 500 lines checklists for for the system, and Kevin would say, "No, man, that's too much." I was like, "There is no way. We need to look into all of this." Kevin, any comments on that? On how it's been to manage the team?
Oh, it's been very challenging, you guys. I'll tell you what, managing you. No, it's been a blast. Honestly, it's just been, trying to identify all the components that were there for the requirement and staying within the scope of all of that as well. So it's been challenging, I think, to the point of having the turnover of people. Once we would get somebody on board, they'd bring them on board. All of a sudden, they'd get a job somewhere or another project, and they had to head out. So it was, I think that was the biggest thing, is the turnover of people, and then making sure that we stayed on task with the scope. There was a lot of, we considered a lot, I think, of the lunar environment in our design than we did more about the competition early on. And I think that led up to some of the challenges too. But no, I'm pretty happy with what we've got, what we've submitted. I don't think anybody else has come close yet. I know that there's a few people that are looking at the Razor design, but we've modified our bucket drums, barrel drums, so that they culminate the regolith inside. And then we have two different methods to scoop it all up. And all of those brought challenges each step of the way to the team. And they just did a fantastic job and helped flush it all out. And then to write it all out, that was the other thing. Writing the proposal.
Yeah, I can relate to that. But I got a couple of questions from the audience. I would like to take them in right now. I've got Michael Nord, that is on the John Hopkins LSIC, and he says that extensive reports exist on many properties of many commercial and available simulants. We don't need to reinvent the wheel. And any comments on that, Ted? Because I think he's offering up overall. He's like saying, "Hey man, there is something over there."
Oh yeah, totally. I looked into those, and for this phase of testing, it's really almost an economical consideration, because we have to run over 500 meters of track, and to really get the geotechnical value out of running over simulant, you need like 30-40 centimeters of it to really sink your wheels into. And a lot of these are a few $100s per kilo, at the cheapest, or maybe not per kilo, but to get a big test track worth of simulant would have been tens of thousands of dollars, if not more. So we could go back and forth and everything, but in order to really get the slope dynamic and the true long distance haulage of the track, we thought a more terrestrial track would be applicable in this situation. So that's kind of why I reached out. And of course, and you'll see even when I screen shared, John Gruner used that you can get lunar simulant here that's manufactured, that's artificial, but I would suggest using bunker sand at this stage in your testing, because lunar simulant's expensive, and so of course later on when we move on to phase 3, I believe we'll be using manufactured lunar simulant. But for now, I think the terrestrial substitution is going to work pretty well for us. But that's a great point. That's a great point that Michael brought up, and I think it's something that we do have to consider.
I think another thing that I would also pull Kevin in is we've been attentive to the LSIC, the Lunar Surface Innovation Consortium, and the amount of information there, and I would say also the sharing. But Kevin, you had a different experience because you were in person with many of them, correct? And with Paul Van Zuzante and a set of people. So what I would essentially like to say is, even across the last days, I've contacted a ton of people. Come on, we've got the NASA award, in my case, as well as the second year that I move into the competition side, and there is this awareness that the work that we've done overall is good. It has an NASA stamp saying, guys, go and fabricate. But we are really open to work with others. Open because overall this is a big undertaking. This is like, there is a lot of stuff that you need to do, and we have a fantastic design, but mostly the part of the relationships and understanding how can we collaborate. I think I learned this from the folks that you guys see in there from the Web3. Like, they have these autonomous communities that help each other. There is also some kind of competition as well happening, but overall it works better than just by yourself. It's a weird thing because if you think about SpaceX, they do them, horizontal and vertically, everything integrated. But I'm thinking that we are like more of, the Grand Bazaar in Turkey. Thousands of shops selling the same thing, everyone working together and bursting the economy. I think that's what we'll be. We'll be a lunar bazaar where we can build everything that you want. If we don't have one of those rugs, someone will have a rug, and we'll clarify that. Can you speak to that, Kevin, to the connection between people, or standing alone, or how is that going to happen?
Well, it's a massive infrastructure that needs to be built, so not one company is going to be able to do that. There's so many moving components and parts that are needed that it's just intense. I mean, the struggles that we went through for me just trying to develop in situ resource utilization components just end to end, so that it covered the entire mining process. That alone was just incredible, just in the integration component. So having structures in place, to be able to build and to manufacture, to launch the fuel tanks off of the moon into somebody like Orbit Fab or some of the other companies that are out there that are going to be servicing in the orbit. So I think there's a lot of different moving parts. We all need to have a little component of that, and in order to do that, it'll make it work. But I think everybody, if one guy is just out there trying to do it all himself, it is just going to fail. And we saw that in the early asteroid mining companies that were after that. They just didn't collaborate, and I don't think they pulled out a lot of detail and information from people. But hopefully we can break that cycle and start small. And if it mines on the Earth, it'll make sure it mines on the moon, and then move on from there. But right now, the moon is the environment that we're after for oxygen and for water, and anybody that comes along and can complement our offering and can provide us with steps that we don't have to create in order to get to the moon, that would be ideal. I saw somebody asked about payload user guides from Astrobotics on one of the questions. We have contacted. I've read through them, and I think right now at this point we're a little bit too early. We're about 2 years away from being able to look at launching. I think we need to test here and validate our system to work remotely and to survive not only the 384-hour lunar day, but also months on end. We're just not up there for a one-time trip. So we have a lot of testing to do here, but we will eventually get to. I like astrobotics. I like iSpace. I like Space IL. There's a number of different components out there that I think we could fit into. So
I want to bring the conversation more into just being clear. We have a design, we have a physical architecture, and we have a functional architecture. We have a design that is locked at the moment. In the old days of oil and gas, this will be an EPC. Okay, it's like the whole idea is that you have this overall bid. You say, this is what I want. I need to have procurement and construction. Okay, that's engineering, procurement, and construction. This industry where we are now should follow the same practices, correct? These guys have made platforms that go under the sea. Someone owns the engineering, someone holds the procurement, and someone holds the construction. And sometimes they all they are all working a conglomerate. Right now we have the engineering, but this is where we are. So we are moving into reviewing the design, having the bomb out there within our needs, and then initiate procurement and construction. And then when I say construction, we will follow that formalized. And from the folks that are in here, and I see Craig in there, and I know that you were about to think about this. We're going to follow that most formal NASA break the ice challenge. Sarah Mitran, she helps a lot people in the space economy. She's asking, which companies do we like? Oh, okay. So please, Kevin, go ahead. Which companies do you like?
Wow. In the competition, I've looked at a couple of different companies that are there. Redwire, I like because they are also following the same pattern of what we're doing with using the Razor as a good foundation to begin with. I think I'd rather reserve my judgment to see and comments on that question just to see who is actually going to be following through with some of this. Execution is by far some of the hardest things.
What we are talking about is manufacturing this, correct? It's not we've done the concept. Now it's about that. I think Sarah is alluding to supporters, which ones in the manufacturing in space, I believe in the space part that could complement our offer. Which ones do you like? This is a hard question because there is a bucket of the ones that you forget to tell and you like them, correct? You talked about iSpace, you talked about astrobotics. I know people from ABA, I know people from Blue Origins. We all know, everyone knows everyone. So I was like saying, oh, I like these guys, and the other ones, oh, come on. So, Sarah, I think we will take that question offline, okay, regarding the companies that we like. But I think from my side, it's someone that is aligned with working as a team. That is more where we are, because we do have this set. You can see, man, Ted has done a fantastic job on. To be fair, one of my haha moments in this was like when you show me the bunker sand, and I was, pushing him with a lot of questions. What about humidity? What about earthquakes or moonquakes? What about electrostatic environment? What about, in some terms, I would act like the bad guy, and suddenly he shows the graph. I was like, done. It's like, done. It has to be there. So that was really, really a very, man, we are going to test it in there. So in order to test that, we need to build it. And we've been having this discussion, an internal discussion that I'm about to disclose. Ready? We need 8 prototypes. And Kevin says, it's not 8 prototypes, Gonzalez. I know. It's 8 subsystems that have different parts.
One prototype with many revisions.
So, yes. So this is where you can, I think, I would like to let everyone feel a bit more of what is Planetoid Minds. And going back to this, Kevin, what do you think? What do you think is the difference between Planetoid Mines and the big companies. And the reason why I'm saying this is the following: we can see, we can go up and we can go up and look at the three big companies in space developing things for the lunar economy, or we can go to Earth and look at the companies that do mining on Earth. And what differentiates us? That's an interesting question, I think.
So
that I've been thinking.
So about 2019, we were looking at doing an asteroid redirect mission and, capturing the asteroid, what it would all take to do that. And then and begin to do a deductive analysis from the bottom up to identify once we had the asteroid, what are we going to do with it? How are we going to mine it? How are we going to extract it? So I began to look at a trade study and a gap analysis of all the different components that were out there that were available and those that weren't. And to identify the entire mining structure. So what I have seen is that there's very few hardware-focused ideals. There's a lot of conceptual ideas of how we can do certain things, but when we get down to the nitty-gritty, we had to really look at who was actually building some things out. I'm very impressed with what Michigan Tech University has done. Paul Van Sutan was one of my early sources. And Paul's research is on what he has done for lunar regolith and Mars regolith and the excavation processes that would work in zero and microgravity has just been critical for us to and for me to come up with a really good solid design to execute. And so those are the things that I really look for in a company, and how if we're going to compare ourselves against others, it would be what are the hardware that they're actually working on? How are they executing it? How are they building it? Seen a lot of concepts that have been presented to me in the past 3 years from a lot of small startup companies. And I've talked to a lot of individuals that are in the space consortiums, let's say, and these other transactional authority companies that are after those OTA contracts. But I've talked to a lot of them, and some of their ideas of what they've had just are not conceivable. Just wouldn't work in space. I saw one the other day of a large wheel that was spinning at a high speed, and its idea was to land on the moon. And when he showed me the animation, the simulation of it, the amount of dust that it kicked up on its moment of impact would have just stayed there forever. It would have been considered resident lunar objects now rather than resident space objects. It would just, the plume of cloud would have just remained. And it continued to roll and did so for maybe another 500 meters, just a vast amount of dust. And I tried to explain that concept will not work on the moon. It will not work because the moon is a harsh environment filled with really all sorts of dangerous particles. And the last thing we want to do is kick up dust. We want to control dust. So when I look at other companies, that's my biggest concern. First of all, will it work in a cryogenic area? Will it work in a permanently shadowed region? Will it work in the dust environment? Is it going to have issues that are going to stop that? And those were a part of the design considerations that we put into this to this design.
So I wanted to pick up on that, and this is a problem that we have, and not being very clear. We do have what everyone that is designing something for the moon has a problem on Earth. That is gravity. It's a good thing because we are alive, but and I just posted something last week on the can get caught in the surface of Pluto. But doing design for moon dust seems to be really, really. I'm not going to say impossible without initial tests, but we had a good amount of considerations in there, essentially using static moon dust strategies. I'm thinking about coatings. We are talking about some ability to move levers, and there are more things coming up. And I remember we talked about EDI, electronic dust removal systems for the rover. But to be fair, and if you guys are listening, okay, looks fun. If we could write it in the specs, but we need to make the power budget for it. We need to ensure that it works. Many of the technology is not completely proven, although Perseverance has had it. The specifics on the active lunar dust management. Think about that. If I have dust in my phone, okay, and I can tilt it and the dust will fall. Okay, that's one. Okay, that's one. I can shake it and the dust will fall. The ones that we are talking about, the electronic ones, is you apply a certain amount of current, and for a second, the dust on the moon that is electrostatically charged, it becomes out of the surface and is able to get out of there, to get out or to fall in this case. But that requires a change in the power budget, that requires a change in the mass, requires a huge test on the technology. So it looks good. It's like, fine. It's really sci-fi. I would love that, like you have a button and you press and the dust would disappear. But right now we are more basic than that, isn't it, Kevin? The angles in the rover are designed to avoid that the dust.
Absolutely. Yeah, we want to encapsulate all the dust that we excavate upon the moment of excavation. In our ISRU components, we excavate icy regolith and contain it inside our system before we apply any thermal conditions to it to change its phase. So we want to capture it in icy chunks and bring it into our system and seal it. So there's been a lot of challenges in that process to get there, especially in a microgravity environment. And then also there's a lot other challenges that we have to face too, as far as the hardware durability and reliability and survivability in those environments. And dust is a factor that can just kill us. So yeah, we designed the cart to be at an angle so that that any dust that would land wouldn't have a flat surface, so to speak, to land on, or a vertical surface, so it would fall down. But at 1/6 gravity, that speed's going to be pretty slow. So we're going to have to make sure that we really control the dust.
I want to put in here some of the questions that I've got. Bas, that is someone that is doing something very interesting in the space economy as well. He's talking about, Sarah Mitran, and she's asking, iTech has leveraged standardization that has been really helpful to them and its customers. Is there a consortium or a non-profit within the space to develop those? Mostly less companies have that funds frequently the dealers have these exercises. I want to pick up on this one, and then I'm going to give you, first of all, you mentioned Paul van Zuzant. Man, he's a beast in a good way. First of all, he helped a ton. Okay, in what they have at MTU is really a fantastic systems engineering process and all their knowledge. So that I want to recognize that. If Paul, you are listening, please come in and tell us something. Second, there are a set of organizations. I belong to the AIAA, American Aeronautics and AIAA, American
Institute of Aeronautics.
American Institute of Aeronautics and Aerospace for the Space Operations Technical Committee. And overall, it's a place where people coming from commercial space can share needs. We've got people from Blue Origin, SpaceX. When you say these names, these guys are. But we've got many people from smaller companies as well. And we've got also the F47 group that is led by a good person, a good friend of ours, Andrew Nelson. He was one of the first persons to do something like Reef is doing, or in this case Sierra Nevada. And there are the ISO organizations, but there isn't, except for the NASA standards when you fly, that you need to adhere to, or that you need to adhere to the systems engineering process. And NASA will tell you, you need to follow these. These are the deliverables. I wouldn't say, I don't know enough to say. Oh, of course, and the LSIC, Sarah. So LSIC is really a good group.
Oh, yeah.
where we
Yeah, what a
overall.
fantastic organization, John Hopkins. That's
Do you guys have
valuable
any other information for people that are listening on bodies or entities that would help on the standardization for space? I'm going to call it space things because it could be from power, anything. I've got any comments on there?
I would say the Lunar Science Consortium out of John Hopkins is probably by far one of the best resources I've seen on lunar capabilities, everything from excavation, construction, regolith simulant components. It's just it's a great resource to pull on. That's why I've been a part of it for a while and just really enjoy the content and papers too. A lot of good posters get presented there too. So that's a great resource for someone who's interested in that. I saw Robert had asked a question about standardization for the components from where we are, but my comments are all gone, so I don't have the question in front of me anymore. But yes, I believe the question was that will there be a standard arise from this? And we would hope to set some sort of guidelines and some policy for excavation. Right now, it just seems like it's a free for all. It's a nation where China's really kicking up a lot of dust on the far side of the moon, and they're doing what they want to do. I think we really need to focus in on some of the other components that are out there too, like just the different methods and ways that we would excavate, the ways that we will control the dust. All of that needs to be standardized, let alone a set of interfaces to connect and commercial service valves that will allow us to connect. That all needs to be standardized too, so that we can share resources upon that. I mean, I would hate to be in a situation 10 years from now where someone needs air and they don't have the right adapter to connect into tanks of air that are there. So, you know what I mean? So all of that has to be globally agreed upon.
So you've got, I think Michael Nord, and I see Charles Hibbins, man. Charles Hibbins is here. He's been in the LSIC for many, many years, and he's also a really good help. There is the MOSA group, the Lunar LSIC Modular Open Systems Approach, the MOSA group, and they are publishing a lot of very, very interesting content, and we are using it, to be fair. So one of the things that it was really great to, when you work in a team, is most of this is Theo reached out to someone at NASA and asked a specific question on the specific part of the lunar environment. And he got the reply. Theo, how much time did you take to get the reply back? Was it?
I mean, probably 15 minutes. I think I've been really impressed with how open people are to sharing information and sharing intelligence and being collaborative in this environment. And that's really encouraging to see the amount of collaboration people are willing to do within space. Everybody's going for the same goal. Everybody wants to see this happen.
Yeah, I feel exactly the same. Like, you go to the LSIC group meetings, and if you are willing to collaborate and bring things, people will help out. Okay, that's very clear. That has been very clear. And there is this kind of, I'm going to call it weird thing, because we are in America, we are all about work and compete and win and all of those things. But I would say, probably because we have a lot of hobby in this, people are really wanting to help each other. Okay, I think that's a very clear thing that I see this that I see happening. Kevin, I want to take this in another direction. How interesting it is to write a NASA proposal.
How interesting is it, huh? That's what you're asking.
Yes.
I think, there's been a lot of value come out of the L Space Academy of proposal writing, but when it comes down to technical writing and describing and refining and defining what you're trying to say, there's only certain certain number of ways that you can say icy regolith, and excavation, and so your process. And so I think the challenge was really in communicating and telling the right story at the right time, how to present your ideas in a concise manner that will communicate your intentions and your technical solution. So I think that was one of the bigger challenges is, how many times can I describe the functionality of this and operationals of this before I really am trying to find more content, more way to describe it. So, and then flushing out all the details, making sure that you're compliant with all the requests and everything that they've asked for. That was one of the challenges. So we always, we had our monthly and daily checks that we went through every period of renovation and revisions, and then at the very last a week maybe before we got done or the time was submitted, we almost scrapped everything, and Gonzalo, you rewrote the whole thing. It was in a matter of like 3 or 4 days or something like that. You just went through and flushed it all out, and I was like, oh my God, we're done. And I was like, a week before the whole thing, I was like, oh, there's no way we're going to get this. I mean, with all the challenges that we had in submitting those elements, that was good. We came through. I'm very proud of the team.
We can only, the question is, one thing that I think that everyone is really complimented in three of ourselves, and non-complimented, because this works both ways, is each person got their own stuff and doing their own stuff end to end. But one thing I think it worked really well, at least from my side, is that we kind of respected a couple of things. We have a functional architecture and we have a physical architecture. That is, the rover needs to go from here to here, do this and this, and the rover has these parts. And the moment we agreed on that, making the durability plan, making the videos, focusing on that, and then what you said, man, that is, how are we going to show requirements completion to this?
Yeah.
That I do believe that table that we've got at the end, and the guys cannot see it because this is confidential material, but it got us all together saying, okay, and I knew that you were doing like a 3 a.m. We were both doing that 3 a.m. meeting or whatever. We were in different time zones. When you got to put the checks in there, and then in doing the durability plan using that is, man, that was for me. This is gonna work.
Yeah, hats off to John Oldman, our mechanical engineer. I don't know if he's on the line with us, but he came through in the past, definitely within a week before the deadline with the SolidWorks CAD model. It was incredible. We had all these conceptual models out there, and we really needed that SolidWorks. And yeah, I was just blown away with how you guys, every one of you, have just come in and contributed and provided just excellence to this report. So that was really cool. Thank you.
I see also a question in here. Is this for a NASA RFP or a NIS SBIR? And that's from Sarah, and she works, I think, a ton with this. And to be fair, I think it's obvious to understand that we have ambitions to go to SBIRs and STTRs. And this was for a specific NASA. Think of it as an RFP. Okay, the Break the Ice Challenge has the same structure as an RFP of NASA. So yes, it having some structure helps, Kevin. Correct.
Absolutely. I mean, we've been after this for the past 2 years. So, I think where we are with this challenge that they have, the Centennial Challenge, is that we're in pretty good shape. I mean, we had hundreds of people start, 41 people qualified or registered at least, and now we're down to 15 people who have qualified to proceed to phase 2. And looking at the other solutions that are out there, I think that we have a pretty good chance at at surviving. I know we're going to make it through the durability test. I know that we can make it through the vacuum chamber, and hopefully it'll perform like we expect it to. And if not, we can make some adjustments along the way. But yeah, very excited for the future. Go ahead,
Ted and Kevin. Where can people reach out and ask you things about? I'm really excited for the test area. I think it mimics, what I've done was like, okay, let me fly to the moon, because you can do that on Google Earth. You select the moon, fly to the moon, select the area, and then I've flown back to the place that you chose for us. I was like, this is a match, this is a match. We are conceptually in my head. We've landed. We landed either in I don't know who's going to take us there. I'm not going to say names, but I have a couple of ideas on who can take our payload. But where can someone reach you out to ask things about the geology or even the work that you've done? What can be done?
Yeah, go ahead and just connect with me on LinkedIn. I'm available on there. I'd love to chat about geology and test track design and lunar mining and all of that. So yeah, feel free to just friend me on LinkedIn, and I'd be happy to talk.
Kevin, what about shameless promotion of our teamwork? And if people either being investor curious people, we do have a job spec to go out, correct? We need a robotics engineer to start.
Right. We have a couple of needs ahead of us right now. First of all, the website will be up hopefully within the week. I've made some revisions to it last night and updated a couple of things, so I think we're ready to go. And then we also need a facility to build. I'm kind of looking for Blue Origin or Lockheed Martin or someone here in the Kennedy Space Center area to offer up their facility that we can be able to fabricate and assemble, because with our go ahead to manufacture and construct from NASA, we've got to wrap this up relatively quick. And then our durability test is in 6 months. That's July 4th. So we've got a short turnaround that we've got to put this all together and to manufacture it. And that's what we're looking for right now. So, and then we also have a couple of openings for an electrical engineer and a robotics software engineer. And we have those that are immediate. We also have a welder's position that we need, someone to help us with the fabrication component, but maybe we can get that with the machine shop that we partner with. So there's a couple of different options out there. And right now I am looking, and if anyone is aware of any other options, please feel free to reach out to me. And the website, we would be able to have some feedback and some communications there if you want to reach out through the website, planetoidminds.com.
So planetoidminds.com, okay? Just write it down. You'll find it. There is a demo in there of some of the extract working. So what everyone is seeing in here is kind of not a rehearsed thing. We have a script, okay? But these are many of the questions that we've had across the delivery of the proposal and the work, okay? And I'm going to say that, like there is a book, space is often open for business. Yeah, we are also open for business. And we have a really interesting design for the folks that are here that like and look into what's called the process of innovation from Matt Ridley, for example. That's a great author on that. We are building up on other things, okay? We are building up on other designs that need to be complemented to be able to survive in the moon environment. It's also known that when you start building these things, other technologies emerge. For example, our fixtures could be better. Our ability to remove dust could be better than others. So it's not only the main product, what's been happening, and you see this happening across a multitude of companies. They focus on one, and then small pockets of things appear. It could be actuators. It could be our software that is going to evolve from ROS, where it is, to another one. It could be our cameras. But definitely, we are
Well,
moving in that direction. Okay, and
well, it's definitely our mineral beneficiation system because that already has terrestrial applications here that we can separate mixed minerals based on their electrostatic properties and electro characteristics. And so that component itself has been coupled with electrostatic wire fence, if you will, and then that'll be placed on a satellite. And our hopes are to go to Lagrange point 4 and 5 and collect all the dust particles that are in the streams and the bands that are there. And that's most likely iron, nickel. We don't know what else is there, but it's freely available to go and capture, and without very level of work is very low too, because it's just floating there. All we have to do is run through it and capture it. So there are terrestrial applications, dual use applications that we have here. We have a solid oxide fuel cell that wraps around a screw auger, and that's our roasting capability to roast minerals. And we use that heat and all the things that we pull out. And then we also are looking at using the base of our mine cart as a lunar cable anchoring system, as a dead man sand anchor. Has the ability to burrow into the soil and below the soil surface of the moon, and has a Camelot connectors on it that will grip into bedrock or breccia that's down there, and we'll be able to suspend cables and hold that on the moon, which is really critical for solar arrays, lunar construction of towers, everything. So a lunar crater radio telescope is another big project that we would be looking for, using our systems as cable anchoring systems. So we have a number of opportunities that are out there, a lot of dual use application. Like I said, our mineral beneficiation system could be working on underground mines here, to where they're just bringing up now pure ore and leaving all the waste material below, and mine carts of just pure ore coming up. So that helps in remediation and mine closure and environmental and contaminated groundwater. We can flush all of that out with our system as well. And then as extract and mine cart combined here on Earth, we could have a ADM manufacturing component. We can use lunar derived composites on Earth, but we can also use the minerals that we extract here, and to 3D print, 3D concrete print. There's a lot of options that we have the ability to do, but refining the mineral, excavating it and transporting it, step one. Refining it, step two. ISRU, making sure those compatible and durable products can sustain the harsh environments. And then probably 2025, 2026, we'll be ready to launch.
Yeah. I got one more question before we go and start closing. That is from Sarah. Would an ion exchange membranes be helpful in the moon?
Would a what now?
I believe she says ion exchange membranes would be helpful on the moon.
Iron exchange membranes.
From my side, I need to go and check on how do they work, to be fair.
I think if she's referring to electrostatic plates that capture, or electromagnetic plates that capture particle ions, I think that maybe is what she's referring to.
I'll check with Sarah, and nevertheless.
Okay.
And of course, we've got, and Bass is asking, gravity is going to be a challenge. Of course, we know that. We did one of the cool things in the study. We studied. Okay, what if we crash against a boulder? Okay, so, and the cool part in there is that when you do that study to understand how much should the wheel take in, you say, oh, okay, I'm not on Earth. Okay, so gravity is not the same. Although the vehicle has the same mass, gravity is not the same. So yes, gravity is going to be a challenge. That's an interesting thing. Charles. Okay. I've got Charles trying to connect these. We'll definitely reach out to you, Charles. Okay, but we are 1 minute past the hour. This was a brutal conversation. Thank you very much, Ted, for coming in, and Kevin. As you can see from Kevin's head, or you heard from Kevin's head, and the depth of Ted, there are a lot of things that need to be done. Okay, but we are going to do one first. We're going to put this extract moving along, working for 15 days, and it might be even more than one extract. It might be a swarm. It might be, call it the name, okay? But we'll for sure comply to requirements. And the requirements are 15 days, excavate the certain amount of simulant regolith within a certain trajectory, okay? These are, the requirements are out there, and that's what we'll do, okay? We're not, that's very specific. We are, there is someone, if you guys know Jordan Peterson, he's a philosopher of probably more on the conservative side, but he talks about, if you can be anything, be just something, but be that fully. That's what we're going to do. We're going to be pick up that thing that has, the bucket drums, make it excavate and move, and make it happen. So, guys, thumbs up, everyone, for this exciting. Theo, thanks for taking time. Kevin, thanks for taking time. Okay, we have a ton of things to do.
Thanks for hosting it. If anyone has any questions, feel free to reach out. We'll be more than happy to answer them for you.
Yep.
Great.
All right.
Thank you very much.
Guys.
Appreciate it. Thanks, Gonzo, for hosting this. Have a good one.
Thanks.
Thanks. Bye.
Bye.
It's done. Okay, we are no longer live.